We want to look now at some of the ways we can get our sample space. So we remember our sample space is what the total events would be in a probability experiment. Now the first one is just basically what we call a basic counting principle. The idea that if one event can happen in R ways, second event can happen in S ways, well, two events can happen in R times S different ways. So the idea here would be that if you've got a board game with a dial of 5 there, and you want to play a score as a sum of two spins, what's the probability of using the number of possible, finding the number of possible outcomes? So, and it's just basic counting principle. Well, in the first one, we've got 5 things that can occur. The second one can be 5 things that can occur. So all up, there's 25. There's the number of elements in our sample space. There. So it's really working out how many elements are there in our sample space. The idea of a counting principle. And then we can use that to go to the next part, with what's a total of 6? Well, the best way to do this is to draw up a table, because you want to get all the different additions that can occur there from that. And that's fine. Draw up a table if it's necessary. It's quite fine to draw up any diagrams, any tables that you need to answer a problem. And remember, it's the idea of getting that sample space correctly. So be really careful to make sure you understand what the sample space is. So doing the additions there, a total of 6, where you can see how many totals of 6 we can get. Once we've got there, we just count them up and get 5 on 25, which is a 1/5 chance of getting a total of 6. And then more than 6, well, then we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We get our 10 over 25, which is 2/5. So that's how we can start use our basic counting principle with a table. The other one another one we can use is a tree diagram. Now you've probably seen tree diagrams before, which is, again, it's basically what we want to do is get our probabilities correct to get a diagram that helps us solve our problem. So we get branches. If we're going along a branch horizontally, that will mean multiply, and that's basically the idea of AND. And if we're looking at branches vertically, that's the idea of the compound event. So it's a different compound event, and that would be the same as OR, which means to add. Now, when we get all our probabilities at the end, they should all add to give us 1, because that should give us our total events. And this is really for 2 or more successive experiments, and we've got to be careful if our sample space changes because of replacement or no replacement. So for example here, a die is thrown and a coin is tossed. Well, how many outcomes? Well, there's our basic principle. A 2 times 6, 2 head and tail times the 1 to 6. There's 12 different outcomes. Draw the tree diagram for that. Well, a head and a tail and a 1 to 6 there. So that's what our diagram starts to look like. And this time we've got Alice, Barbara and Carol on a committee to find captain, vice captain and secretary. Well, how can this happen? Well, we've got Alice, Barbara and Carol there, and if Alice is chosen to be captain, then they can't be vice captain, and then it'd have to be Carol would be there and Barbara from there. So really, once you've got to the 2, everything's 1. There's a probability of 1 for all our third branch there. So we can see that once they've been chosen, there's no replacement there. So the probability that Alice would be captain, well, there's 1 in 3 chance. There you can see Alice, and then Barbara, Alice and Carol. So there's an idea of how tree diagrams work. As I said, this is just a refresher. You've done these before. It's a case of making sure, if you're going to use a tree diagram, that you get your branches right and the probabilities that go along them.